So firstly, we are going to begin with the transforming principle experiment. Okay, now what I would want you to do is whenever we are doing these experiments, please write down what was done in the experiment, and finally what is the observation, and then what is the result or the conclusion of the experiment. Because you will get questions asking you things like what was the observation. Now the observation is not the same as the result. You know this. I believe you do practical experiments also in your school, right? Observation is a different thing, result or conclusion is a very different thing. So sometimes they'll ask you the observation of the experiment. Sometimes you would be expected to know, give the final conclusion. Sometimes they will ask you to write the procedure, what was followed. Okay, so you need to know the procedure, you need to know the observation, and finally you need to know what is the outcome of that particular experiment. Okay, now we're starting with the transforming principle. In 1982, Frederick Griffith, in a series of experiments with Streptococcus pneumoniae, which is a bacterium responsible for causing pneumonia. Okay, pneumonia is a respiratory disorder, right? So it's caused by this microorganism or bacterium, which is called Streptococcus pneumoniae. So Frederick Griffith worked with Streptococcus pneumoniae, and he witnessed some miraculous transformation with the bacteria. Okay, now again over here, look at the date. Okay, the year 1928, Frederick Griffith. Now, when Streptococcus pneumoniae, that it's also called as pneumococcus, okay, in short, if you grow them on a culture plate, some are going to produce smooth, shiny colonies. Some are going to produce rough colonies. Okay, now please look at the two plates which are given down over here, or the two culture plates or media that is given over here. The first one, if you see, look at the way the bacteria is growing. It looks extremely slimy, it looks shiny, it looks smooth, right? The first plate over here. Look at the second one. This is just to show you the difference. The first one is pneumonia, that is Streptococcus pneumoniae. Second one is to show you the difference between a smooth colony and a rough colony. Okay, you will see here that it does not shine, it does not look smooth, rather it looks little rough. Okay, so these are the two kinds of colonies that Streptococcus pneumoniae can produce if you are going to grow it on a nutrient medium or a culture plate. Okay, so he designated the smooth shiny colonies as S, okay, and the rough colonies as R. Firstly, right? Now, why does one particular type of this Streptococcus produce smooth colonies, and why does the other one produce rough colonies? So this is because the S strain bacteria have a mucus polysaccharide coat. Okay, so they basically, if this is the bacterium, okay, let us say this is the bacterium. Around the bacterium, it has a polysaccharide coat. Okay, what is polysaccharide? Polysaccharide is nothing but sugars, right? Long chain sugars. So this polysaccharide coat is going to give it that shiny, smooth appearance. All right, where this is the S strain, whereas the R strain, which is the rough strain, this one just is like this. It does not have the mucus polysaccharide coat, and therefore it gives a rough appearance. Have you understood this? This is the basis of his experiment. Any doubts over here? Please also remember this, that Streptococcus pneumoniae is called as new. Have you understood so far? Okay, can we quickly, I'll just ask you a couple of questions. Once I'm sure that you've got this, we will proceed. Yeah, Meher, you can tell us what are the two types of colonies that are produced on a culture plate for Streptococcus pneumoniae. What are the two strains that you would see?
Ma'am, there's a smooth strain and rough strain. The smooth strain is the one that contains the virus.
Contains the virus?
Like it produces the in the bacterial, like when you grow it in a culture, it produces the coat, polysaccharide coat.
Yeah, that is not the virus. I don't know why you said virus. Are you getting confused with something else?
No,
This is
ma'am.
nothing. I'm just talking about a bacterium growing on a plate. That's all. So it
Yeah.
can grow in two ways. Okay, since there are two strains, one is a smooth one is a rough one. Nothing to do with virus here. So the smooth one would have the polysaccharide coat, the rough one will not have it. Okay, that's all. What he did is he injected or he infected the mice. He took some mice and he infected some of them with the S strain, he infected some of them with the R strain. He wanted to see what is happening. right? So the mice infected with the S strain. Now, please remember, S strain is the virulent strain. Virulent is the one that can cause infection. Okay, virulent in the sense this is the strain that can cause infection. It mainly causes infection because of that polysaccharide coat around it, which is not there in the R1, right? So therefore, S strain is virulent, R strain is not virulent. So when the mice is infected with the S strain, which is virulent, the mice die from pneumonia. So they develop pneumonia, they develop the infection pneumonia, respiratory disorder, and they die from the infection. But the mice which is infected with the R strain, they will not develop pneumonia. This is because they are avirulent, which means they do not have that polysaccharide coat around it. Okay. So I want you to take down what's given in red over here. Now, this is the thing, right? So S strain, this is obviously the virulent one. This is injected into the mice. What happens? The mice will die. Okay. The R strain, it's avirulent, does not have the polysaccharide coat. If this is injected into the mice would live. This is the basic. He's not doing any sort of treatment to the bacteria. He's just injecting the bacteria as is. Okay. S mice will die. R mice will live. Now, Griffith was able to kill bacteria by heating them. Okay. So I hope you know that you can kill bacteria if you heat them, right? So what do I mean? Of course, that is why we boil water before you drink it, right? You a lot of what do you say, treatments that we do is mainly by boiling or by heating. That is because we want to get rid of the bacteria. Similarly, Griffith thought of the same thing and he killed bacteria. How did he kill it? He heated the bacteria. Okay. Now he heated the bacteria, he killed it. He observed that heat killed S strain bacteria injected into mice did not kill them. So what did he do now? He heated the S strain. Okay, heat. So when you heat it, it's called heat killed S strain. Then he injected this heat killed S strain into the mice to see whether the mice still die or do they live. But in this case, they live. Okay, so if the bacteria is heat killed, they would live. Is this understood up to this point? Yeah. Now, when he injected a mixture of the heat killed S strain and the live R bacteria, the mice died. Okay. Moreover, he recovered living S strain bacteria from the dead mice. So think about this. Now, he's killed the S strain, he's heat killed it, he has mixed it with the R strain. R strain he has not heated. It's just as it is. How we did it in the first stage, it is the same way. So he just mixed the heat killed S strain with the R strain, live strain without heat killing it. And now he has put this mixture into the mice. Okay. You would usually expect that the mice should live. Reason being, the R strain was anyway not virulent, right? This was avirulent. He has also killed the S strain. So ideally the mice should live, isn't it? But the mice died. Okay, now once the mice died, he was also able to recover the S strain bacteria from the dead mice. So what do you think would have happened here? This should have actually, the mice should have lived ideally, but it dies. What do you think would have happened over here? Any idea? Angelina, what do you think?
Ma'am, some characteristic of the S strain that made it virulent must have gotten transmitted to the R strain.
Correct. So it would have got transferred. Yeah. Okay. Okay. Now before that, let us just look into this. The rough strain is non-virulent, smooth strain is the virulent one. You can see the coating around it, right? The yellow coat is nothing but the polysaccharide coat. Okay. This is the smooth, heat-killed smooth strain. Just look at this. Now, if you inject the rough strain, that is the R, into the mouse lives. Okay. If you inject the smooth strain, which is the S, the mouse dies. Now you heat kill the smooth strain and then you inject, the mouse lives. But if you're heat killing the smooth strain and also adding the R strain, mixing it up and adding it up, the mouse still dies, which means that there has to be something that's getting, if this one is dead, there's something that's getting transferred to the rough strain, which now makes it like the smooth strain, and then it is killing the mouse. He concluded that the R strain bacteria had somehow been transformed by the heat killed S strain bacteria. Okay, that's why it's called as the transforming principle, because some transforming principle transferred from the heat killed strain. Okay, so what would happen? This, he did not know what is getting transformed or what is getting transferred. He just called it as some transforming principle. It transferred from the heat killed strain, went to the R strain, and now the R strain was able to synthesize a smooth polysaccharide coat and it became virulent. Do you understand this? The R strain is a rough strain. It does not produce the polysaccharide coat. But when you mix it with the heat killed S strain, it is able to do so. It is able to produce a smooth polysaccharide coat and it becomes virulent. So therefore the mouse dies. Okay, which means something from the heat killed S strain got transferred to the R strain, because of which the R strain is now able to produce the polysaccharide coat and kill the mouse. Okay. Now, this must be due to the transfer of the genetic material, right? So, the genetic material which has the gene for producing the polysaccharide coat would have got transformed to the R strain. But again, he did not have any proof of it. However, the biochemical nature of genetic material was not defined from his experiments. Okay, so how exactly, what kind of genetic material is it? What are its characteristics? What is its biochemical nature? Nothing could be defined from his experiment. All he could tell from this experiment was that something's getting transferred from S heat killed S strain to R strain, because of which the R strain is making a coat now, polysaccharide coat. It's becoming virulent and it's killing the mice. Okay, so what is the conclusion of this experiment? The conclusion is these pointers over. These two are the main conclusions. Okay, that something's getting transferred, and you have to say this could be due to the transfer of genetic material, but this is not defined or told in this experiment. So this is also called as the transforming principle experiment. Okay, or you can also say it is Griffith's experiment. Any of these names could come up. Okay, list that, explain transforming principle experiment, or explain Griffith's principle, or Griffith's experiments with streptococcus pneumoniae. All right, it could be asked in any way. You have to explain all of this. Mainly the red pointers here is what you're supposed to explain in writing, and finally you have to give the conclusion like this.